you.
Hello, everyone. My name is Dan. I'm on the data science platform team at Bloomberg. So data science platform at Bloomberg shares the same vision as Kubeflow. So we facilitate everything cares about data science. We facilitate data science daily work and try to automate all the machine learning workflow life cycles. And our platform has been running production like for 2 years now. We have hundreds of data science running daily training jobs on the platform. And they run notebooks and TF jobs, like such as TF jobs, and they use also launch Spark job for ETL. And now, since like they train models, there's a lot of demand on serving their models on production. Serving model on production has a long list of requirements to check out. And it's a tremendous challenging task. And we have to support various model types such as TensorFlow, PyTorch, scikit-learn, as well as our in-house model types for natural language processing. Since last year, we start to build the inference infrastructure for our platform. And we talk to a lot of users, and a lot of time the users just ask, they just want to implement a function, little function called like a predict, transform, or like a drift detection. And they want our platform to take everything else. Then we start to look at a few open source solutions, such as serverless, mainly the serverless solution, such as OpenFast, OpenWhiskey, or Kubeless. And we found that none of them like satisfy our long list of requirements. And Knative actually came along later, which provides a set of building blocks for serverless. And then we started to build our infrastructure on top of Knative. So we created an abstraction called Lambda CRD, which is a function which composed of build, serving, and eventing. For example, the predict is a Lambda function, and the models, and we also have this model CRD, which is just a facade of Lambda CRD, which is more friendly to data scientists. Why Knative? Knative extends Kubernetes to provide a set of serverless building blocks with a standardized interface. Knative build orchestrates the workflow from source code to image. This is critical for data science who don't necessarily have knowledge about Dockers or any like cloud DevOps. So all they care about is just write a little function, and then we can easily turn them into an image. And Knative serving provides auto-scaling capability. They can auto-scale from 0 to n. So you can easily scale up and down your service based on your need. Scale down to 0 is particularly interesting because if you have a precious resource such as GPU, so you don't want to long-running service like occupy your resource like all the time when your service is idle. And abstractions of like service and revisions and routes, which are critical for our production ML model serving a workflow with like a canary rollout and rollbacks. And Knative eventing enables capability for building inference graph with such as you can have like a feature transformation and to prediction and to concept drift detection, outlier detection without writing any plumbing code. So with all these building blocks, we create a Lambda CRD, which is composed of build, serving, and routing, and with a function can have input and output channels. So this is how a Lambda CRD looks like. And we have a build on the build step. Data science can just specify where's their function code repo, and what's the revision of their function code, and where they want to publish the Docker image. And then Knative build basically orchestrate the entire workflow from source code to image, which is entirely abstracted away from the data scientists. On the serving spec, you specify which function you want to serve, what is your Python package name, and how do you want to scale up your application. you can also specify a minimal number of instances if you want to, if your service takes some time to start up, you don't want to pay the cost of a cold start. So you can always specify the minimal number of replicas that you want. And you can also specify the metrics class. We support like a native Knative default scaling metrics, which is based on the QPS. So if your application is at 500 query per second, and your each pod you are targeting to only like 10, then Knative will spin up like 50 pods to serve your model. And you can also do percentage-based routing. So when you, this is very good for your production workflow. Whenever you want to route a new model, you want to set a small percentage, like 20% or 50%. And once you are confident about your model, then you can like increase to 100% to your new model. And on the channel spec, you can specify input and output channel. So if your model listens on the are processing the prediction from a Kafka topic, and then you can basically specify your channel as Kafka, and then the topic you specify your topic name. Then Knative will automatically spin off a Kafka consumer which subscribes the topic and automatically triggers a function. So user will not need to write any single line of code to do this plumbing work. So all they need to is submit a Lambda CRD, it automatically wires up. So, we also have this concept of model CRD, which is basically a facade of Lambda CRD. So data science, like they don't want to like care about how, so on the Lambda CRD, where, for example, the TensorFlow serving, there's a little details about like how you want to launch the container. You have to specify the command, args, and all this, how you launch a container. And it's just we do everything what we can to make a data science job easier, just abstract all these details away. And then all they care is just a model URL. And then we will basically do some translation in between, and under the hood is still submitting a Lambda CRD, which spawns a bunch of Knative components. So this is a diagram describing how high level how this entire pipeline looks like. So let's say you want to write a little function which you have write a little function for. Let's say you have a NLP model you want to serve, and you have news articles coming on the Kafka topic, and then you want to do some sort of a classification task, and then you write your predict function to serve your NLP model, and then you compose the Lambda CRD I just described, and you kube control apply that CRD, and then basically it will launch a build job first on the cloud, which build your function code and use our predefined build template. That will result in a serving image. So after image is published, it will automatically trigger a deployment job, which launches the Lambda deployment for your prediction service. And the service, when service startup, will load the model from your storage, and it automatically subscribes the input channel for that for your Lambda function, and also connect to your output channel. So when a news article flows in a Kafka topic, it will automatically deliver your the event to input channel, and then it will automatically triggers your prediction Lambda service. And once you got the prediction result, the result will get delivered to output channel, and you can basically change the other Lambda functions you wrote for any like sort of post processing. So we also use since you can have many Lambda functions, and then we also use Istio to build a service mesh where you can have an ingress gateway. to secure and for the single gateway to access all these services on the mesh. So we can also enforce the authentication and authorization to your service. Basically, it makes your service more secure. Right now, I'm writing a proposal to the community to discuss how we can integrate to the Kubeflow with it, bring the serverless to the inference part. So we actually, our platform started around the same time as Kubeflow. We built like a very similar features such as like TF operators. We have very similar features on our platform right now. And at this point, we decided to like also join the community and share our experience and contribute whatever we help build. Hopefully can contribute back to the Kubeflow. And eventually hope one day we can converge and just use Kubeflow instead of our stuff. Thank you.